Now we move on to solving absolute value inequalities. With this type of problem, you will need to pay attention to the direction of the inequality and the sign of the constant over on that right-hand side. Let's start fairly simple, just as we did in the last section when we dealt with absolute value equations. The absolute value needs to be isolated, as usual, before we go on. And again, we begin by interpreting the inequality so that we can make sense of the form of our final solution sets. Here we interpret this as find all solutions whose distance from 0 is less than 3. Now remember to go to the right and the left of 0. Since this is an inequality, there are infinitely many solutions, all between -3 and 3. Therefore, we use the interval notation to say just that, all real numbers between -3 and 3. With that one problem behind us, let's talk about how we formally, or rather algebraically, solve this type of inequality. Keep in mind, what is stated on the slide only works for those cases when we have a positive constant over on that right-hand side. We will consider the other cases, the special cases, later. We take out what is inside the absolute value and place that in the middle with always two less than inequalities, the negative of the constant on the left and the positive of this number over on the right-hand side. Here the absolute value is isolated. We have a positive constant with the less than inequality. Because we have the less than inequality, the expression in the absolute value gets taken out and put in the middle with two less thans. -5 goes on the left, +5 goes on the right end. You are done when x is isolated in the middle. Remember, what you do to one part, you must do to all three parts. The solution set of this type of inequality will always be the numbers trapped between two values. This time, our interval notation says all real numbers between -1 and 4. Let's now consider the absolute value inequality with a positive constant and a greater than symbol. Again, to interpret this, we will read this as find all numbers whose distance from 0 is greater than 5. Notice how you go on forever in the positive and the negative directions. With that one problem behind us, let's talk about how we formally, or again, algebraically, solve this type of inequality. Keep in mind, what is stated on the slide only works for those cases when you have a greater than symbol and a positive constant. We will consider the other cases with negative constants at the end of this. Take out what is inside the absolute value and place that as the right-hand side of our two separate inequalities. The inequality with the less than is set to the negative of that constant, and the one with the greater than is set to the positive of that constant. You will always have two separate inequalities to solve, and they will be joined by the word or. The absolute value is isolated. There's a positive constant on the right. We're dealing with the case with the greater than. With this type, the inequality will go on forever, for our solution set, in the positive and the negative direction. Expect to solve two separate inequalities. The far left part of our solution set comes from taking out the expression in the absolute value and setting this to less than or equal to -3. The right part of our solution set, the part that goes on forever in the positive direction, gets set to greater than or equal to +3. Solve these two inequalities, joined by the word or union, and you've got your answer. Now here's a special case, since the absolute value is isolated and we have a negative constant. There is not an algebraic way to solve this kind where the constant is positive. For this, what we have to do is just interpret this. Since absolute value makes all numbers positive, or 0 for one number, we ask ourselves the following question. When is a positive greater than a negative? You respond with always, which means all numbers work, or your solution set is all real numbers. On the second special case, we would ask ourselves, when is a positive less than a negative? And you respond with never or nothing works, your answer is no solution. It'll be very important that you isolate the inequality, pay attention to the direction of the inequality and the sign of the constant over on that right-hand side. Hopefully this has been helpful, and thanks for listening.